Hello. In this video I'll explain the spectral unmixing feature of the Imalytics Preclinical software. So the purpose of spectral unmixing is to analyze or quantify multispectral images, and here I generated an artificial dataset containing 5 wells, and it has 4 channels, and let's go through them here. These are the 4 channels, and go back. And the wells contain 2 substances, A and B, and it has here 100% of A in here, and then 0% of A, and in the middle it's 75, 50 and 25%. And for B it's a bit more complicated, but I'll explain that later. So let's generate some regions here of A and B to extract the spectra. I will create a cylindrical region of A and B, and a background region, create region. Now here on unmixing you can press Save Class Spectra. That will generate a file here, so I'll write that, and I prepared an Excel sheet to look at that. It's actually a comma separated file, so you can open it with Excel. These are the spectra of A, B and the background. So A is more bright on the first channel and B most bright on the last channel, and background is everywhere. But what you can see is there's a little bit of B in every channel and of A also in every channel, so we can use no channel to really separate A or B from each other. So if we just perform quantification, so let me load a segmentation of the wells here. These are 5 wells segmented. Now you can perform here quantification that computes an Excel sheet for each channel here, for example like this, channel 0. But I prepared an Excel sheet also to look into that. So if we look at the amounts here of A in the 4 channels, we see that here in the first channel it separates it decently but not well, and in the other channels it's not good at all, and for B it's similar. So here the last channel separates it decently but the other channels don't work well. So if I look back at the spectrum, this explains why no channel is really good to separate them, because there is crosstalk in every of A and B into every channel. So the spectral unmixing separates each voxel based on its own spectrum into these 3 components. So let's execute that here, unmixing, spectral unmixing, and there you have to select the previously generated spectra file, and after a few seconds it loads it as underlay. And so this shows the first component, and we see that here we have these 5 wells, and here we actually don't see anything, and that's good because there is nothing in there. And if we go to the other channel here, it's the other way around, and there's a last channel also. This is just the background it computed. So if I now load the segmentation of the wells and compute the statistics for these, you can look at that with Excel, and I prepared that as well here with the unmixed, and there we can see a nice correlation for component A and component B, also between these are the known amounts and the measured amount here, known amount and measured amount, and very nice correlation. So to repeat that, the spectral unmixing helps you separate components that have overlapping spectra as shown here in this example. Okay, thank you.